Hi guys, let's start a new chapter, graphical solution of simultaneous linear equations graphically. We've earlier done a chapter was simultaneous equations where we learned to solve simultaneous equations using various methods, one of which was substitution, another was making the coefficients of a variable equal, so coefficient equal, and then one was cross multiplication. Another method of solving linear equation or simultaneous linear equations is graphical. If you remember the equation, the simultaneous the linear equation, which means basically a straight line, it was given by ax plus by plus c is equal to 0. And when we were doing our previous chapter, I told you that the equation for a straight line, standard straight line, is y is equal to mx plus c. Basically the same, just the coefficient may be different. So let's revise graphical solution, or rather learn how to plot equations of a line, which we've already done in our last chapter. So a quick revision. So the first one that we do is x is equal to 5, which means x, the value of x is 5. Whatever be the value of y, x will remain 5. So this is 5, 5 and 5, whether y be 0, whether y be negative 2, whether y be positive 2. So this is x is equal to 5, 0, this is 5, negative 2, and this is 5, 2. So this is x is equal to 5, that's what I am plotting. I will take a scale and I'll join these three lines using a straight line. Notice that you will have to use a scale. I do not have access to a scale on this software, so I'm using a freehand. So I put an arrow on both sides indicating it's a line, which means extends indefinitely, and this I put what I have plotted, which is x is equal to 5. Now let's do the next question. I'll use a different color. So this is y is equal to y plus 7 is equal to 0, which means y is equal to negative 7. Again, like the last one, here the value of y remains negative 7, whatever is the value of x. So y always remains negative 7, whether x is 0, x is 2, or x is negative 2. So let's plot these points. 0 with negative 7, which is here, 2 with negative 7, which is here, and negative 2 with negative 7, which is here. Perfect. So now let's join this line, and again you will use a scale. This is extending on both sides, and I have plotted y plus 7 is equal to 0. Let's move on and let's do the next question. The next question that we do is question number 1, part 6, which says 3x plus 2y is equal to 6. So 3x plus 2y is equal to 6. I'll write it in the standard form of y is equal to mx plus c, which means this will become 2y is equal to 6 minus 3x, which means y is equal to 3 minus 3 upon 2x. 3 minus 3 upon 2x. So if x is equal to 0, then y will be equal to 3. So x is equal to 0, y will be equal to 3. If x is equal to, yes, if I want this to be a whole number, which means I'll take x as multiples of 2. So if x is equal to 2, y will be equal to 3 minus 3 by 2 into 2, which is 3 minus 3, which is 0. So if x is equal to 2, y will be equal to 0. And then the last one, I hope you remember, we need to plot at least 3 points. Let's look at the last one, which is if x is equal to negative 2, y will be equal to 3 minus 3 by 2 into negative 2, which is 3 plus 3, which is y will be equal to 6. So if x is equal to negative 2, y will be equal to 6. So now let's plot these points, 0 with 3. So x is 0 and y is 3. Yes, this is 0 and 3. The next is 2, 0. So this is 2, 0, and then the last one is negative 2 with 6. So negative 2 with 6. So this is my point, and then we will join these points using a straight line. Let's join them. Keep extending on both sides. Notice that I can't use a scale, which means my line is looking crooked. this is x, this is 3x plus 2y is equal to 6. Perfect. This is basically a revision of what we've already done. That brings me to the last question on this slide, which is x minus 5y plus 4 is equal to 0. This is your part number 7. X minus 5y plus 4 is equal to 0. Again, I'll write it in the standard form y is equal to mx plus c, which means this will become 5y is equal to x plus 4, which means y will be equal to x plus 4 upon 5. So let's take some values of x, and if x will be equal to 1, y will be equal to 1 plus 4, 5 upon 5, which is 1. So if x is equal to 1, y will be equal to 1. If x is equal to, let's say, 6, y will be equal to 6 plus 4 upon 5, which is 10 upon 5, which is 2. So if x is equal to 6, y is equal to 2. And if x is equal to, let's say, negative 4, y will be equal to negative 4 plus 4, that's 0, to 0. Notice that every time it is jumping by 5 because in the denominator I had 5. So if you want this to be a whole number, you will have to jump the value of x by 5. So 1 jump by 5 gave me 6, 1 jump by 5 on the other side gave me negative 4. These are certain tricks that you will have to observe and notice as well. Let's move on. So 1 with 1, that's my first point. Next is 6 with 2. So 6 and 2. And then the last one is negative 4 with 0. So these are the 3 points, and I join them using a straight line, using a scale, and extend it. This gives me x minus 5y plus 4 is equal to 0. Thank you so much. Bye-bye. Let's look at the next question. The next question is question 2, part 1. It says draw the graph for each equation, hence find the coordinates of the point where the graph meets the coordinate axis. So we need to figure out where the graph meets the x-axis and where it meets the y-axis. So let's look at this. This is 1 by 3x plus 1 by 5y is equal to 1. So let's solve. What do I have to do? I'll take the LCM. So LCM of 3 and 5 is 15. So this becomes 5x plus 3y is equal to 1, which gives me 5x plus 3y is equal to 15. I'll convert this in the standard form of y is equal to mx plus c. So this gives me 3y is equal to 15 minus 5x, which gives me y is equal to 15 divided by 3, that's 5 minus 5x upon 3. Perfect. So I'll have to take values of x as multiples of 3 so that I get a whole number. So let's look at some values. If x is equal to 0, y will be equal to 5 minus 0, which is 5. So if x is equal to 0, y is equal to 5. Now if x is equal to 3, y will be equal to 5 minus 5 into 3 upon 3, which is 5 minus 5, that's 0. So if x is equal to 3, y is equal to 0. And if x is equal to, let's say on the negative side, if x is equal to negative 3, y will be equal to 5 minus 5 into negative 3 upon 3. So that's 5 plus 5 is equal to 10. So if x is equal to negative 3, y will be equal to 10. So now let's plot this. 0 with 5. So that's my this point. Next is 3 with 0, which is this point. And then the last is x is equal to negative 3 and y is equal to 10. So negative 3 with 10. Negative 3 with 10. Perfect. So let's take a scale and join these 3 points in a straight line. Notice that I do not have access to a scale on this software, so you will join them using a scale line. What I have drawn is 3y is equal to 15 minus 5x. So what we need to figure out are the points where it meets the x and the y axis. So this is 3, 0 and this is 0, 5. So here we'll write the points where graph meets coordinate axes are 3, 0 and 0, 5. Perfect. Let's look at question number 3. Question 3 says draw the graph of the straight line given by the equation 4x minus 3y plus 36 is equal to 0. Calculate the area of the triangle formed by the line drawn on the coordinate axis. Perfect. So again, we've done this kind of question in our previous exercise as well. So let's still look at it. So this gives me, let me put it in the form y is equal to mx plus c. So this gives me 3y is equal to 4x plus 36. Yes, 3y is equal to 4x plus 36, which gives me y is equal to 4x upon 3 plus 36 divided by 3, that's 12. Again, I'll have to take values of x as multiples of 3. So if x is equal to 0, y will be equal to 0 plus 12, that's 12. So x is equal to 0, y will be equal to 12. Let's look at the other one. Just if x is equal to, let's say, negative 3, y will be equal to 4 into negative 3 upon 3 plus 12. So that's negative 4 plus 12, which gives me 8. So if x is equal to negative 3, y will be equal to 8. So I'm going down on this side. So let me take another value of x. Let me take x is equal to negative 6. So if x is equal to negative 6, y will be equal to 4 into negative 6 upon 3 into 12, which is 3 into 2. So a negative 8, this is not multiply, this is plus, sorry. So negative 8 plus 12, which means 4. So if x is equal to negative 6, y will be equal to 4. So let's plot 0 with 12. Perfect. Negative 3 with 8. That's negative 3 with 8. Next one is negative 6 with 4. Perfect. So let's join these using a straight line. And if I join them using a straight line, again going in this direction, and this will extend in this direction. Perfect. So what they want, so I have already, and what I need to do is write the line which I plotted. I plotted 4x minus 3y plus 36 is equal to 0. Let's read the question. What do they say? They say calculate the area formed by of the triangle formed by the line drawn and the coordinate axis. So this is the red line is my line drawn. This is coordinate axis 1. This is coordinate axis 2. So they basically want me to find this area. So let's name this. This is A, this remains O, and this is B. So area of triangle AOB, which will be equal to half into base. In this case, base is OB into OA. Now, where does B meet the x-axis? This is at negative 9. So is my OB negative 9? No, it cannot be negative 9 because distance can never be negative. So this is 9. And what is OA? OA is 12. So and the unit will be square unit since we are looking at area. So 2 into 6. So this is 6 into 9. That's 54 square units. So the area is 54 square units. Perfect. And that's about it. I'll see you with the next set of questions. Let's look at the next question. The next question is question number 5. It says draw the graph of the equation 4x plus 3y plus 6 is equal to 0, and from the graph find some things. So let's first find the value of, let's draw the graph, and then we'll see here what do we need to find. So 4x plus 3y plus 6 is equal to 0. I will write it in the form y is equal to mx plus c. So this becomes 3y is equal to negative 4x minus 6, which means y is equal to negative 4 by 3x minus 2. Yes, negative 4 by 3x minus 2, which means I'll have to take value of x as multiples of 3. So if x is equal to 0, y will be equal to 0 minus 2, which is negative 2. So if x is equal to 0, y is equal to negative 2. The next one, if x is equal to 3, y will be equal to negative 4 by 3 into 3 minus 2. That's negative 4 minus 2, which is negative 6. So if x is equal to 3, y will be equal to negative 6. Let's look at if x is equal to negative 3, y will be equal to negative 4 upon 3 into negative 3 minus 2. 3 and 3 gets cancelled, so that's 4 minus 2, which means 2. So if x is equal to negative 3, y is equal to 2. Let's plot these 3 points. So 0 with negative 2 here. Next is 3 with negative 6. 0 with negative 2, 3 with negative 6. So here it is. And then the last one, negative 3 with 2. Negative 3 with 2. Perfect. Now we'll take a scale and join these 3 points using a scale. So let's look at this. So here, let me join this, and 1 second, you need a scale to draw a straight line. Perfect. Now that we've drawn it, let's see what the question is. We need to find the value of y when x is equal to 12. Oh, so when x is equal to 12, what will be the value of y? So let me just extend this line and see how far it goes. So let me just see. Oops. Here I repeat, I do not have access to a scale. This is how it looks like, and let's see what else do they have. And this is when x is equal to negative 6. So this is on the other side. If x is equal to negative 6, what will be the value of y? Perfect. So I have extended on both sides. What I have plotted is 4x plus 3y plus 6 is equal to 0. They want me to figure out the value of y when x is 12. So where is x is 12 on this graph? Here, this is x is equal to 12. At this point, I draw dotted line from 12 onto my graph. This will help me find the coordinate of y where x is 12. You will draw these dotted lines using a scale. I have drawn using freehand. So where it meets, I draw a dotted line onto the y-axis. Here, you will draw a dotted line to the y-axis here. So this is the point where x is equal to 12. What's the value of y? As per my graph drawn, it is negative 18. So this is the point that they wanted. Here there is one thing that we need to add. Since we have been given value of x, which means my first dotted line was from x axis, I plot or draw an arrow going towards the graph, and since I reached the y-axis, after reaching this point, I put an arrow reaching 18. I repeat, since the value of x was given, which means I started from this point x, which is x12, I drew a dotted line onto the graph. So I draw an arrow starting from x going onto the graph, and from here, since I went to the y-axis, I draw an arrow reaching the y-axis, which means I started from x and reached y, and that's how I am able to figure out value of y. So value of y1 is negative 18. Let's look at part 2, the value of y when x is equal to negative 6. So again, when x is equal to negative 6, from here I will draw a dotted line onto the graph. When I reach the graph, I will draw a dotted line to reach the y-axis. Again, since I start from the x-axis, I put an arrow from the x-axis going to the graph, and from the graph going onto the y-axis. So this is where I reach. So the value of this point is negative 6, which means the value of y when x is equal to negative 6 is 6. Perfect. Let's look at the next question. The next question is question 6. It says use the table given below to draw the graph. So we'll draw the graph in a couple of minutes, and then it says using the graph find a and b, and then after finding a and b, state a linear relationship between the variable x and y. So this part is new, which is stating a linear relationship, and it is important as well. It is almost expected that the question from this exercise will have state the linear relationship, which you will have to calculate. So first let's draw the graph and then we'll look at it. So the first one is negative 5 with negative 2. So this is negative 5 with negative 2. So this is my point, negative 5, negative 2. The next one is 3 and 2. So this is 3 and 2, and then the last one is 13 with 7. Well, obviously I cannot plot negative 1a because I don't know the value of a, and I can't plot b5. So let's join these points using a straight line. If I join them, I would notice that let's see where they fall, right? So let's see. Yeah, it is taking me time to draw using a scale. I hope you would be able to draw it more fluently. Perfect. So next is I need to figure out the value of y when x is equal to negative 1. So this is x is equal to negative 1, and notice that this is lying on the y-axis itself, which means a is equal to 0 when x is equal to negative 1, y is equal to 0. Perfect. Next is value of x when y is 5. So this time I am starting from the y-axis, so I draw an arrow from the y-axis going on to the graph, and from there I draw an arrow or a dotted line going to the x-axis. All these dotted lines will be done using a scale. This time I started from the y-axis, so an arrow starting from the y-axis, and this time I reach the x-axis, so reaching at the x-axis. It's always a good habit to write the point which has been where you reach. So this is 9. So b is equal to 9, which means when y is equal to 5, x is equal to 9. Perfect. So now let's look at the second part of the question, which is state a linear relationship. We've already done that. The standard form of an equation is y is equal to mx plus c. So what I need to figure out is the value of c and the value of m. If you look at the graph, I notice that the value of c is 1 because that's where it's touching the y-axis. But this is not the best way of calculating it. Let us see how it can be done. So let's look at it. Let's take any two standard points on this from this graph, and let's replace their values in my standard form of the equation. So let's look at the first value that I want to look at, which is, let's look at this. So if I replace x with negative 5 and y with negative 2, it should give me some equation. Since negative 5 comma negative 2 passes through this line that we want to create, y is equal to mx plus c. Let's substitute y with negative 2 and x with negative 5. So this gives me negative 2 is equal to negative 5 m, I don't know, plus c. So let's call this equation 1. So I've got one equation. Let me replace and another point. So let's this time take 13 and 7. Since 13 7 passes through y is equal to mx plus c, let's look at it. So y is 7, m we don't know, x is 13. 7 is equal to 13m plus c. So I have a set of simultaneous equation. Let's call this equation 2, and let's solve these two simultaneous equations the way we've learned. So negative 2 is equal to negative 5m plus c. I notice that the coefficient of c is equal, and this is 7 is equal to 13m plus c. So I will subtract negative, negative and negative. C and c gets cancelled. So negative 5m minus 13m, that's negative 18m. And negative 2 minus 7, that's negative 9. Which means m is equal to negative 9 upon negative 18, which is half. Therefore, m is equal to half. So I've got one value of m. Let's put m is equal to half in one of the equations. So put m is equal to half, let's say in equation 1. And what do we get? Negative 2 is equal to negative 5 by 2 plus c, which means c is equal to negative 2 plus 5 by 2, which means negative 4, that's half. So then c value is equal to half. Now we know the standard equation is y is equal to mx plus c. Let's substitute values of, so c we got as half and m also we got as half. So let's substitute these values. So y is equal to m is half x plus c is also half. That's ideally you should never leave your coefficients in fractions. So let's take the LCM. So this will be LCM will be 2. This will be x plus 1, which means your answer will be 2y is equal to x plus 1. That's the standard equation, or rather that's the equation of this line that we've plotted. This is 2y is equal to x plus 1. That's about it. Let's look at the last question in just a couple of minutes.